thank you everyone for attending this webinar on driving EV digital development through advanced simulation synergy. So let's start with mentioning some of the major industry trends. We have connectivity such as V2V, V2X, and even passenger connectivity to the internet. We have obviously the ADAS and autonomous vehicle trends for increased comfort and safety, and the electrification trend in light of the latest European regulation. All of those and more represent increasing complexity and justifies a need for digital development. At VI-Grade, we have identified 3 levels of synergies: shared results, shared models, and shared KPIs. The shared result level is the most basic one, where relevant tools are used for each subsystem, and the results are shared across departments to allow for more accurate boundary conditions and inputs. The model sharing level is a little bit more advanced. Development teams directly provide their knowledge by sharing their own detailed models of subsystem. This allows for enhanced accuracy thanks to simulation, and each team can leverage higher fidelity digital twin. Finally, the highest level of synergy is a shared KPIs one. In this level of synergy, teams are no longer pursuing their targets in siloed environment, and the vehicle is developed at the global level. It leads to an accurate global estimation of performance. It allows comprehensive overview of global targets, and team can analyze the impact of their own modification on the goals of other divisions. And this is where VI-Grade and its simulation tools come in. But before getting into how, let's go back to our industry trends. In this webinar, we are focusing on the electrification challenge. It's a challenge because you need to combine a new drivetrain with the batteries, the BMS, the motors, the inverter, and all of the control logics to the more traditional approach of vehicle dynamics with your KNC setup, packaging, and weight distribution concerns. You could approach both independently, but considering them together raises the quality of the development process. To demonstrate the workflow, we'll use for the drivetrain a model-based design, which has been made in MATLAB Simulink. And for the vehicle dynamics, we're using a parametric reduced order dynamic model that has been designed in VI-CarRealTime. But what is VI-CarRealTime? First and foremost, it's an accurate and performant parametric real-time vehicle model. It's the only real-time solution on the market that can seamlessly and automatically import models from Adam's car and or KNC results. It allows the vehicle model, which is real-time, enables engineers to quickly and easily perform large-scale DOEs, so design of experiments, and multi-objective optimization studies. Finally, our model is uniquely adapted to both offline and online simulation and can be used on driving simulators, be that of VI-Grade or other companies. In this demo that I'll be showing next, I will present a powertrain Simulink model. I will then show the electric crossover car real-time models that we have developed, and I will show how to conduct a consimulation between the two of them. Then I will show how to export the Simulink to car real-time and show how to modify the model and conduct analysis. So let's start with the powertrain Simulink model. We have developed a complex enough model of an entire drivetrain. The idea is for the powertrain division to simulate this powertrain accounting for vehicle dynamics. So this model contains the ECU with a bunch of inputs and outputs. We have also the electric motor, same inputs, outputs as you wish. We have modified the battery management system, and we have also modelized the battery. Finally, there are a bunch of initial parameters that you can set, and you can obviously do that as you wish and as you see fit. So let's now see the VI-CarRealTime dynamic model of the electric crossover. So in the VI-CarRealTime software, I have already prepared a vehicle model, which I'll be opening right there. All major subsystems have a dedicated user interface. So you can see that we have all of the major subsystems here, and you can go down in detail. For example, the body, you can see that we have different tabs, and you can input your parameters in a very, very easy way. Same for front suspension, rear suspension, etc. Before moving on with the vehicle dynamics team passing on the model to the powertrain team, we're going to use the diagnostic mode, which is a new feature of VI-CarRealTime 2024. It has several predefined events, which are designed to test lateral and longitudinal performance, as well as the overall setup. For this application, I have already defined a set of events to run. So loading it here, we can see that we have 3 events, a ram steer event. As you can see, there are several tests in it, a static setup event, and a sign steer event. You can set the parameters and thresholds as you see fit. We can now run all 3 of them. And as it runs, as I mentioned, this is a brand new feature of the latest release of VI-CarRealTime, which makes it really easy to benchmark your vehicle model against your own internal criteria. Mauro will then present more features. Now that the simulation is done, we can look at the report. You can see that all the checks are green and everything has been validated. You can select the one event that interests you most and see the criteria. For the co-simulation, now that the model has been validated, we can pass it on to the powertrain. VI Grade provides a VI-CarRealTime module in Simulink, so you can see it here. You can choose from a bunch of inputs and outputs, and you can also create your own and add them to the VI-CarRealTime model. You have an input file given by the vehicle dynamics team, which gives information on the vehicle model. And once all is set up, you just need to run the simulation as you would normally would. And if we open the data inspector, we can see in this event, which is an acceleration event, the metrics that interest us. In this case, we have the torque and the temperature. Now that the model has been validated, by the powertrain team, they can give it back to the vehicle dynamics team. And to do that, they just need to build a model using a plugin provided by VI Grade, making sure that the parameters of the simulation are the same as VI-CarRealTime. Once you do that, you just need to build as you would normally would. And it creates a number of files, 2 of which are most important. We have an XML file and a DLL file, which must be passed on to the vehicle dynamics team. So you can see the 2 files here, and you would just do a transfer of files. Going back to VI-CarRealTime, I have already gone ahead and added the auxiliary subsystem to the model. So let's open that. Now going to the main interface, we can see that the auxiliary subsystem has been added in. And if we go to the dedicated tab, you can see that all of the parameters that are defined in Simulink are present and their value as well. Now that the vehicle dynamics team has a complete model, it can conduct an on-track dynamic simulation. So in the test mode, we can see that a bunch of events are already predefined. Some are industry standards, some are more advanced. In this case, we're going to do a track run, a flying lap on the Kalabugi track. And the trajectory has been previously optimized by our own driver model, VI Driver. One of the 2024 version of VaultE, which you can see on the right, is that you can modify the parameters of the simulation directly in the interface, and you don't have to go ahead and modify the files. So the simulation takes a bit of time, and I've accelerated the process. But once that's done, we can visualize the results thanks to an internal tool called VI Animator. So going to the review mode, we can see our event here, and we can visualize it in VI Animator. So in VI Animator, you can visualize any data. Here we have the default one, but you can also create your own. Here we have the driver demands, for instance. You can see tire information. And so I'm going to go ahead and add the battery temperature to the plot, which we have previously defined in Simulink. And we can see the trend, and we can also see the numerical value. If you run the simulation, you can visualize the vehicle performing the event. The arrows represent the tire forces, and you could even add some widgets to visualize RPMs or speeds, for instance. And if you noticed on the graphs, you have a tracker which shows you where in the simulation you are. Now, the vehicle dynamics would like to upgrade the crossover to a sports version, so we're going to do just that. I will open the model. Some of the parameters I've already gone ahead and changed. Namely the anti-roll bars have been scaled up. So on the front 1.1 and the rear a little bit more for a more oversteering behavior. We have also changed the spring preload. To modify the powertrain parameters, you don't need to go back to Simulink. You can do it directly in VI-CarRealTime. So in this case, we can increase the battery mass and the battery capacity to simulate a more powerful battery. And for convenience, I have already gone ahead and updated the lookup table of the electric motor, just to not have to change a bunch of parameters live. But you can do everything from the interface. So the team can now rerun the Calabugi event to see how the sports version compare to the regular one. So you can copy an event and then just add the correct version of the model you want to try. You just need to run the event. And once again, since it's a full flying lap, it does take a bit of time. So I went ahead and accelerated that by the magic of video editing. Finally, you can compare and analyze the two models in VI-Animator. So if we go back to our review mode, we can see that we have the two events. And by selecting the entire fingerprint, we can visualize both of them. So in yellow, we have the reference model. And in blue, we have the newly created sports version. If we look at the graphs, it's quite easy to see that the sports car has a better performance as we have expected. But to get a more concrete sense of how, you can also visualize it directly thanks to the animator. So you can see that the focus here is on the sports car, and you can see how it compares to the yellow one. And you could also have a better sense of the tire forces thanks to the arrows that you can visualize here. Obviously, you could put the focus on the reference models as well. Now, I'm going back to my battery temperature, so I'm adding the plot again. I could have saved also the configuration, so I don't have to do it all over again. But since it's only one, it's quite easy. And when we look at it, we can see that the sport version has a battery that is temperature that is getting quite hot. So that would be a good idea to go back to the powertrain division and tell them that we have made a sports version, but it might create some issue for them, and so they can handle it for their own KPIs. So some highlights of this demonstration. We have seen the seamless co-integration of VI-CarRealTime and MATLAB Simulink. We have seen that you can run a VI-CarRealTime model in Simulink and have Simulink model as an auxiliary subsystem in VI-CarRealTime. We have seen the efficient collaboration across team and departments with the vehicle dynamics and powertrain teams collaborating, and they can easily evaluate their impact on the other team KPI. The workflow is simple and the results are accurate. You just need one file exchange to have a subsystem that can be modified directly in VI-CarRealTime, and you do not have to go back to Simulink every time. And we have seen the diagnostic mode, which allows to validate the performance of the vehicle. As I said, this is a novelty of the VI-CarRealTime release 2024.1, and now I'll let Mauro present the new features.
Thank you, Jody, for the very interesting demonstration. And today I will take you some time to put some highlights on the new features, on a few of the new features of the VI-CarRealTime 2024.1 version that has been released recently. Okay. The first item, the first new features of which I would like to talk is the functional mockup units subsystem. A functional mockup unit FMU is one of the most popular standards in automotive industry, and not only automotive, to share entire subsystem or individual components developed by different environments and in different departments. Supporting FMU connection is a crucial part for component usability and for collaboration and for model accuracy. For all these reasons, and to make the use of FMU components as easy as possible in VI-CarRealTime, we have completely redefined the FMI interface in the new version. With this last version, by importing a valid FMU in VI-CarRealTime, the user has the possibility to interact from the GUI of the software with the FMU, using a wizard to connect output of the FMU to input of VI-CarRealTime and vice versa, and also all the parameters can be tuned directly from the VI-CarRealTime interface. In addition to that, bringing the FMU parameters inside VI-CarRealTime makes it possible to use them as candidates for the investigation. The FMU-based workflow has also been extended in order to make it easy the interaction between VI-CarRealTime and under-the-loop platform. Up to earlier version of VI-CarRealTime, it was possible to configure and create an FMU embedding the VI-CarRealTime model only for Windows. Starting from this new version of VI-CarRealTime, we also added the support for an FMU export for Linux real-time on PXI HIL, and the generation of this FMU can be done directly from the interface of VI-CarRealTime. The same approach will be extended to other HIL platforms in the future. Another functionality that we introduced recently in VI-CarRealTime and that we announced in 2024.1 is the definition of actuators. With 2023 release, we implemented the possibility to define actuators using actuators topology, so it was possible to define in VI-CarRealTime the attachment points and the attachment bodies of actuators, which exist of different type, single component force, inline force, or general force with 6 components. But before this latest release, it was only possible to define the topology in VI-CarRealTime, and in order to define the force components, it was necessary to move to a different tool and to use one of the available interface to VI-CarRealTime, either an FMU or a Simulink model or a solver plugin. With version 2024.1, we provide the possibility to define the force component magnitude directly in VI-CarRealTime through a pretty flexible expression builder, where the user can combine measures that are basically alias to VI-CarRealTime outputs, state variables, differential equation, and parameters to build the force as desired. In addition, in case the set of built-in function and of variables available in VI-CarRealTime should not suffix to the generation of a complex force component, it is also possible to embed in VI-CarRealTime user-defined algorithms implemented through C-code interface. Still in terms of modeling, one item to highlight in terms of driveline modeling is the introduction of the torsional degree of freedom for sideshaft. For model topology where a drive shaft is defined. So whenever there is a front or rear differential, or the motor is or an electric motor acting directly on the wheel, it is possible to define a flexible side shaft. When this happens, VI-CarRealTime introduces an additional degree of freedom between the wheel spindle on one side and the motor or differential on the other side, and introduces this degree of freedom to a model, to an ampere parameter model using shaft inertia, stiffness, and damping. Another area of VI-CarRealTime worth mentioning for 2024.1, where a lot of improvement has been done, is the investigation mode. The improvements that we implemented are both on the experiment definition point of view. So for those who may not know, VI-CarRealTime investigation mode is the tool in VI-CarRealTime that allows to define experiments for design of experiments, and definition of experiment was limited in earlier version to parameters of the VI-CarRealTime model. It's of course a wide range of parameters, but there were some limitations. With 2024.1, we introduced the possibility to include as parameters for the investigation the FMU, the parameters of any FMU which is connected to the model, as I mentioned before, the parameters of Simulink model to be executed in co-simulation with VI-CarRealTime, so it is possible to directly consider in the design of experiment, as a design of experiments factor, the parameters defined in the Simulink workspace of the model. And it is even possible to introduce as a parameter to introduce as a component some parameters of the event. For this version, the possibility to introduce event parameters is limited to the Kennedy events, but we are already planning to introduce general parameters for a VDF file as candidate. Last, let me also speak a bit about the diagnostic tool, which has already been mentioned by Jody before. This is a diagnostic mode is a completely new operating mode in VI-CarRealTime that basically allows to define test easy to run test suite in which after each simulation, the software automatically performs tests of user-defined metrics against a number of threshold, against the user-defined threshold. The software already provides a number of a set of user-defined tests, but the full power of the diagnostic mode can be obtained when defining your own test case. So there is an automatic procedure in VI-CarRealTime that allows to generate a test case for diagnostic mode out of a generic test, and a set of Python API allows to define your own test to create your test suite. The results of a diagnostic event are then collected in a very easy to understand report where the failures, failing and success tests can be easily identified. Last, we also updated Adams car plugin for VI-CarRealTime Adams car plugin to match all the advancement in the VI-CarRealTime vehicle model, and we also introduced the support for a new version of Adams 2023.1. All the features implemented in the VI-CarRealTime model are now supported also on the Adams car plugin side. And with this, I think I concluded my short overview of VI-CarRealTime new features, and I hand over again to Jody to proceed.
Thank you, Mauro, for this very complete overview of the novelties of VI-CarRealTime. So to conclude this webinar, we are going to see how the digital development process has been leveraged by Mercedes-AMG with the VI-CarRealTime. So the challenge for Mercedes was to manage the increased complexity in vehicle systems that we mentioned before, while ensuring seamless digital development processes. They found a solution in VI-CarRealTime, thanks to the features that I've presented earlier, such as direct co-simulation, importing of subsystem, and integration into other systems. This allowed to streamline the evaluation and design processes. The value brought by VI-CarRealTime to Mercedes-AMG, it allowed to reduce the dependence on hardware prototypes and helped from the design process to the validation process of the V-cycle without having to build the prototype, which in this case is the hypercar. It accelerated the development cycles, and it fosters a collaboration with suppliers, such as Tier 1 suppliers, through faster iterations and shorter lead time. If you want to know more about this paper, it's linked in this presentation that you will receive later, or feel free to reach us through email at info@vi-grade.com. So let me just run the little video prepared about this project between VI-Grade and Mercedes-AMG. So in addition to VI-CarRealTime, you have seen a VI-Grade driving simulator as well as the graphic interface. Thank you so much again for your attention during this webinar. And to show you we mean it, we have an offer especially for you. By scanning the QR code or going to our website vi-grade.com, you can get 15% off on one of the coming VI-CarRealTime trainings. So either in Europe next month or in the Americas the following week. After the training, you will get for free a VI-CarRealTime license, which can last 30 days. And you will then have the opportunity to purchase the software with a 15% discount if you buy before the end of April. Thank you, everyone. Goodbye.
Bye-bye.